Dr. Grissom, and for today we are going to just be going over the phase two, all the lectures and all the code. It's very simple but very technical on, again, using the data sheet and knowing your registers and bits and all that. So let's just begin. Uh, as you can see, in the code, I'll always have some comments that I wrote from the lectures because I find it that I always start forgetting stuff, right? So I want to always remember when I view some of this code, okay, yeah, this is what some of the main takeaways were. And so the first thing was you need four chords and you need to have the SCA and SCL, which is the serial clock pins, to be set to 32 and 33 respectively for the VNCL 4040, which is a proximity sensor that detects the objects. And then, yeah, that's pretty much the gist of that one. And then the lowest level you want to have that we have the device is the microcode, and then we have that Arduino, and then Adafruit. But it's important to communicate to any I2C device, which is why we're going to one more level, and that's kind of the importance of that. And so, I did change the code here, and the main reason I did change some of the code here was because the sensor was not working, and I didn't know why. And I was getting a green light, but the sensor wasn't working. So it took me about 2 hours to just mess around with each jumper cable, like just keep messing with them, and then eventually I got it working. So that's why I had this. Oh, does it detect the 060? Because that's our sensor. Which actually, in the next one, you'll see that that was kind of the goal of that one. And just to make sure it's working, I mean, we can just run it real quick. And then basically, just to show that it is working, I will touch it. There'll just be a photo of the sensor. There's not really an LCD screen for this part. So there'll just probably be one photo, but it should be fine. All right, so as you can see, it is saying no hand detected, and then when I get close to it, it detects my hand. So there you go, just to prove that it worked right there. And then obviously we delay a statement, then unsigned nature. So that's it for that one. Okay, so for the next one, you as we don't want to delete the libraries because it shows like it taking forever and crash like the video you were showing that you were demoing, and then also we want to find we need to find how many I squared C addresses there are, and you recommended to just use Google or ChatGPT just to do a quick search on that. And then we can also do a bit shift to see what's given on the terminal and to see if the device is there or not. And then after that, we have to use these pins that can also detect each address, which is 21 for internal, 32 port A, which again, it shows on the back here, which I actually have it connected to, yeah, 32, 32 and 33, which is supposed to. And then we begin. Byte response, again, 1 byte for the variable to hold that response for the I squared C, and then it shows the number of devices found on that actual bus. And then we also are using 128. The number why we're using 128 is for all addresses 0 through 127, 127 plus 0, 128, and that could be found on the I squared C bus, right? And then 400 hertz is the maximum, so we just jumped this to 40,000, like you showed in the video. And then we start the scan, and then after that we just attempt to do a hello world, pretty simple here. And then print the actual device found. And as you can see, it found 060, so it did find the sensor. That's pretty much it. Just basically detecting, and then all the little maximum hertz, all the addresses, and then don't delete your libraries. That should be a wrap up for that one. Scanner. Device ID. I think we'll do this one next. Okay, yeah. Okay, so while this is uploading, basically what we have here is that we declare our variables, 32 port A, address for the VNCL 4040, and then we want to initialize the actual port, and then we use the graph shown in the actual data sheet for basically like following order, like the command, and then the the square brackets, and it shows the arrows. That's the ones you want to follow And just like we did dumb bytes to read here. Then we begin the transmission. We pass in the VNC 4040. Make sure to pass the address, which we did. Then we write to it, and then we end it, which false. Basically, just end it. And then we request to read the data from the register from the above. And then we grab that data line, expecting a 16-bit data. So we initialize that to 0. So that's pretty much how that works. And as you can see, it finds 0x186, which again, we did do the bit shifting there. Okay, this next one is we would have to, again, rewrite stuff if we're working with multiple devices, but because this is only one device, this code works, which you do mention that we do have to rewrite. That's why I thought that was important, because you did say we were going to be working with multiple devices later. And then you can reset the device, and it will read the same time every time. As soon as it loses power, it gets wiped and updated. So again, if it still has power, you can still reset it. You're going to get the same numbers. But if you turn the power off, and then turn on, then it's going to update to a different number, right? And then we obviously want to define our VNCLs. And actually, I messed around here, which you did chip ID and ALS. I tried to do PSMF on the data sheet to understand it a little better. And then we have our unsigned integer pass through our register address. And then we set that up to begin passing through all of our pins. And then through that, we test it, and then we give it through a loop, and then given the 8-bit address, writes that provided 16-bit data into the register address, which we just pass that through in. We begin the transmission like the other one, which enables the connection, and then we write to the LSB, MSB, and then send all the data. And then here, this is just 16-bit data, which I thought was important. And then we prepare and write the address using the command code, which also is the register code. And then we end the transmission request to read data and write data. Sorry, not write, but register address from above. And then we grab the data to the line using an if statement and passing through the register and the hex. And as you can see, we have 3 right here. And those are the correct ones on the data sheet. Yeah, this was the one I did not mean to show because it just goes along with this one, so that was my bad. But first thing to do is include our header put the header in the include, so this works, and then we can run this while I can explain it. And then we just define registers just like that time. Begin always, pass our pins. Then we write registers through the VNL sensors, then hexadecimals. And then we loop it, which we don't loop actually. And then we call the read sensor proximity data to print. And then we call the read sensor ambient data to print. And then we call the red light and data to print. And then we delay it so it's not reading the sensors too frequently like we had last time. And a very interesting thing in the video was shown here, which 65535 is equals to the 2 to the 16th. For every bit, it will increase to 0.1 lux. That's why we actually multiply it by 0.1 up here. ALS times 0.1, RLW times 0.1. And so, yeah, just a little neat fact. And just to make sure it is working. Let's run this again.